So we know that energy is released in the form of ATP. A molecule of ATP looks like this. It's made up of a 5-carbon sugar called ribose, 3 phosphate groups, and the base, in this case, adenine. And you'll recall that adenine is one of the 4 bases that you'd find in a DNA molecule. The full name of ATP is adenosine triphosphate. And this relates directly to its structure. Adenosine because adenine is the base, and triphosphate because 3 phosphates. ATP is a really good immediate source of energy for the cell. It's an excellent immediate source of energy, but it's a very bad long-term store of energy. And the reason is these phosphate bonds, the bonds between phosphate groups, are very unstable. They have a low activation energy, which means they're very easily broken. So that is an advantage if you want to just release a small packet of energy as and when you need it within the cell to power chemical reactions as they happen. But it's not a good way of storing energy long term, because you'd have these phosphates pinging off all over the place. So you need to know a bit about how ATP can release energy in this way. The process of breaking one of these phosphate bonds is called hydrolysis. And hydrolysis requires water. So following the hydrolysis of one of these phosphate bonds, we end up with a similar looking molecule to ATP, but this time with only 2 phosphates instead of 3. And the remaining phosphate is free. So breaking one of those phosphate to phosphate bonds results in the release of a small amount of energy. And that phosphate can be useful. So ATP can be a source of phosphate groups, which will become important later on. Now, just as easily as ATP can be hydrolyzed, all the phosphate bonds can be hydrolyzed to release energy, ATP can be reformed through the opposite process of condensation. And condensation releases water. So if we wrote this out in full, ATP can be hydrolyzed to ADP plus a phosphate. And the conventional way of writing a phosphate is Pi. It stands for inorganic phosphate. And the reverse situation is ADP combining with a phosphate to regenerate ATP. So this way is condensation, and this way is hydrolysis. Now, the whole point of ATP is that if you just required a small amount of energy for a chemical reaction, and you just broke up a glucose molecule, you would release a huge amount of energy. Most of that would be wasted as heat, which would be unfortunate. So what happens in our cells is that glucose is used in the process of respiration to release energy in the form of molecules of ATP. And these molecules of ATP can diffuse to areas of the cell where energy is needed, and to hydrolyze these phosphate bonds one at a time to release manageable amounts of energy so that as little as possible is wasted as heat.